Welcome to DataPlatformGeeks webinar. Today's webinar is on SQL Server Statistics by Amit Bansal. I'm Manohar Puna, I'm your host today, and Satya is helping us with moderating the webinar. Before we start the webinar, let's quickly go through a few slides. DataPlatformGeeks, you're already part of this community. If you have joined this webinar today, this is a subsidiary of eDomino Solutions. It's a community initiative. Mainly concentrating on data platform and open source. There are also companies under eDomino brand like SQLMaestros and Peopleware India who specialize in training pan-India and also online. Please do explore their sites. There's a lot of learning content available on their sites. The fourth year of the conference, Data Platform Summit, has been announced. It's happening for 3 days from 9th to 11th of August. And there are 2 pre-conference full-day trainings on 7th and 8th of August. This is happening in Hotel Radisson Blu in Bengaluru, which is formerly Hotel Park Plaza. And you can visit tps10.com for more information about the conference. This is a 3-day pure learning event. It's not a marketing event. We have 2 pre-conference trainings, which are full-day deep dive technical trainings on specific topics. There are more than 100 sessions and over 50 speakers who are coming from all around the world, like the data group product team members from Redmond are joining us, and also world-renowned experts, MVPs, MCMs, and industry experts are participating at this conference. This will be a wonderful opportunity for you to network and learn from these experts. Let me quickly introduce you to the core team behind Data Platform Geeks community. Amit Bansal, who is also our webinar speaker today, is the founder and president. Myself, I'm Manohar Puna, I'm the vice president. Avnish Panchal, Prince Rastogi, Sandeep Pani, Yogeshwar Pul, and Surbhi Agarwal are the core team members and are the backbone of this community. And you meet few of these guys at our local events, at the in-person events, and also during our online events. eDomino teams also support us in running these events across India. A special shout out and thanks to Microsoft in building this community and help us organize these events and get data platform and data platform geeks grow bigger. If you're attending the webinar today, you would have already registered at dataplatformgeeks.com. If you haven't got a chance to explore, please do visit dataplatformgeeks.com because there's a lot of content available which will help you grow in your career. Like there are blogs, videos, labs, and magazines, and all the content available on this site is free. So you just need to register, which is also free, and you get access to all this content. And the largest SQL group on Facebook is the SQL Geeks, which is the Data Platform Geeks official Facebook group. So please join this group. You can post your questions and also answer some questions. And this is one of the biggest groups of data platform on the community sites. And I would quickly hand over to Amit Bansal, our speaker today. Over to you, Amit.
Thank you, Manohar, and very warm welcome to all of you. Now, let me share my screen first. Just give me a second. All right, friends, thank you, Manohar, and good afternoon, good evening, good morning, where you have joined from. SQL Server Statistics is the topic for today. And let me first make all of you aware that I am running on poor internet connection, and if my voice is breaking or it's not clear, please call it out and maybe I can switch over to an alternate backup internet device that I have. So today might be the session might be a bit shaky, so please bear with me. Manohar has already introduced eDomino and everything about eDomino, so I will quickly move over these slides and just introduce myself to you. My name is Amit Bansal, and I have been working with SQL Server since 1999. I have worked with SQL Server in various capacities, as a developer and database administrator, and now I focus a lot on performance tuning. I am also an MCM and an MVP with Microsoft Data Platform. Some of these initiatives were launched by me, as Manohar spoke just a few minutes back. In case you want to learn more about me, the URL is there at the right last bullet point, sqlmaestros.com/Amit-Bansal. Now, friends, today I do not have any slides. I really have all demos. So today's session is a very heavy demo-oriented session. And I am going to talk about the internals of statistics. I'm going to focus on what statistics are, why are they required, how are they created, how are they maintained, and of course, as part of maintenance, how are they automatically updated? And of course, the last piece is going to be, how does the SQL optimizer consume the statistic data? This is going to be the overall content. Let me switch over to the VM and we will get started with the demos. Now, I am assuming that many of you already know what statistics are, but a quick introduction so that all of us are on the same page when it comes to statistics. Now, let's start from the very basics. When you send a query to SQL Server for execution, a lot of things happen. Amongst those lot of things that happen, one of the things that happen is the optimizer creates an execution plan, and your query is executed based on that execution plan. Now, it is your expectation that the execution plan will be really the best plan that the optimizer could create. And even that is the expectation from the optimizer. The optimizer would give you the best possible plan for your query execution. In order for the optimizer to do that, to create that best execution plan so that your query runs fast enough and performs really well, the optimizer is heavily dependent on statistics. Statistics are that one object that SQL Server, that optimizer really needs to compute what we call as cardinality estimation. Now, what's that cardinality estimation? It's about the estimated number of rows that the optimizer needs to process to execute your query. Now, let's say, for example, you say select star from a table where column 1 equals to some value. Now, when you say, well, let me give a real example. Let's say you say select star from orders table where order date is equal to April 12, 2018. Now the optimizer needs to do some guesswork. It needs to know an estimation as to how many rows will actually match or will be equal to that particular date, which is April 12, 2008. For the optimizer, now optimizer cannot do a guesswork here. There could be a million rows, there could be just one row, or there could be no rows at all, which means an empty result set. But then how does the optimizer create a good plan if it does not know, or if does not have an approximate value as to the number of rows that will match that particular constant or that literal or the parameter? That's why optimizer is heavily dependent on statistics. Statistics are the object which will give that indication to the optimizer that maybe approximately 50 rows are equal to April 12, 2018. Sometimes the statistics are very accurate, and you will see estimated number of rows are 50 that optimizer estimates, and when the query actually executes, you see 50 coming back, 50 records coming back, which means actual number of rows matched exactly with estimated number of rows, which is 100% success and perfect cardinality estimation. Sometimes it might happen that estimated number of rows is like 40, but you get 50 rows in return. And sometimes things can go really bad. The optimizer can say the estimation could be like 1 million rows, and you just get a few handful of rows returned back. So you see, if estimation goes wrong, the plan is bound to go wrong. And if you want to ensure that you get the best plan and the best optimized plan from the optimizer, two things are really important. You have the right statistics in place, and they should be updated. In the absence of either two, if you do not have the right statistics, or if you have the statistics but they're not up to date, there is a possibility that optimizer may not produce a good plan. Now, this concept of statistics is very similar to everything that we do every day in our day-to-day life. And think about you organizing a birthday party for your children, and when you organize a birthday party and you want to take a stock of what kind of food you want to arrange, and you want to really find out how many friends who are coming to your party are vegetarian versus non-vegetarian. So what you do is you kind of do an RSVP, and you go, or maybe you call all your guests and find out whether they're veg or non-veg, so that you can decide the menu items on the food platter. So these are so what are you doing? You're doing a small survey. You're going and knocking at every guest, asking a few questions and getting the response back, and you are preparing a summary. That's exactly what SQL Server does with statistics. Statistics will go and do a sampling, or it might just go and touch every row in a particular column and take those column value and prepare the statistics objects. So there's density factor, there is histogram, and there are a lot of these things that get computed. That's why statistics is data about data, and that's why we call this as a metadata, which is data about column data. Now, statistics are created on columns. They're not created on the whole table. They're created column wise, and you could have statistics on a single column, or you could have multi-column statistics, which is stats objects on multiple columns. And what these objects, statistics objects, they contain distribution of data, how they're spread out in the column values. And going back to in the beginning, what I explained is then this data is used by the optimizer to estimate a good plan and to perform cardinality estimation. So in summary, that was a very, very high level overview, a very quick overview of what SQL Server statistics are and why they are so critical for the optimizer to prepare a good execution plan. And the bottom line of that is your query should run fast enough, and statistics play a very, very critical role. Now, one small thing to all of you: many people confuse between statistics and indexes. Now, the confusion is not that everyone knows that indexes are a different objects and stats are different objects, but sometimes people think, I mean, both of them are the same things, and kind of and why that confusion happens is because statistics are automatically created when you create indexes. Now, let me tell you, indexes and statistics are completely two different objects, and indexes help you to get faster to the data. Indexes are retrieval mechanism. They just help the execution engine, the storage engine, to get to the data faster. Indexes don't really help the optimizer in creating an optimized execution plan. Yes, of course, your plan will say whether you should be seeking on an index or scanning an index or whatever the optimizer wants to do with the index, but all that happens is at the layer of execution, not in the planning phase when the optimizer wants to create the plan. Well, with this basic introduction, let me get started with the demonstration now. So first, I'm going to use this table, database AdventureWorks 2012. And I want to do a quick check before I get on with the demos. I hope everyone is able to hear me and they're able to see my screen. And I just executed the statement on AdventureWorks 2012. You are able to see all of that. You can just type yes in the chat window, and I will get a signal that, yeah, things are going well, and I will continue. Wow, it's yes from almost all of you, which means internet is working good. Glad to see that. Okay, so let's get started. There is a table here. There is a table here called person.person. Let me first drop that table. Okay, so now I am creating a copy of this table, person.person, as person2. And I click on execute. And let me just show you what this table is. So I've just created a copy of person.person, and this is a heap now because no objects exist. And you can see that this particular table has first name, middle name, last name, and a couple of other columns. Now, when I run sp help stats for this particular object person.person2, this sp underscore help stats is a system stored procedure, and it clearly tells me now that this object person.person2 does not have any statistics or indexes. And so because it's a heap and it's a fresh new object that I have created. Now, when the interesting thing here is when I did select start from person.person to, remember when I do this, and then when I run help stats again, you will see still no objects are created, no stats object exists, because you are telling the optimizer by saying select star, which means give me all the rows. And when optimizer has to just give you all the rows and there is no filter, optimizer does not really need any statistics because you're just asking for all the data. And the optimizer is just going to create a very trivial plan where it just has to create a very simple plan of getting all the data. But now when you say select start from person.person, where last name is equal to Bansal, optimizer needs some information about what really this last name is and what kind of data it has, how many values match, which is equal to Bansal or any other last name value. It needs some information. So when you execute this, it is now going to create a statistics object for last name. And now when I run sp help stats and I click on execute, you can see that SQL Server has created a statistics object on last name. That's my statistics keys and the name of the stats object. Now this is automatically created by the system. Why? Because there is a database property called sp sorry, not sp, that's stored procedure. The setting is auto create statistics. That setting is turned on, and that's why SQL Server is now automatically creating statistics when it feels that there is a need of a statistics object and one does not exist. So it goes ahead and creates it. Now, when you look at this naming here, it's an automatic naming convention that's used. 3B9FD2F1 is the hexadecimal value of the object ID. Last name happens to be the 7th column. So it's all 000 and 7. Sys stands for system. WA stands for Washington. I'm not getting there. That's what I read somewhere, that's what SQL team just prefixed WA as Washington there. So that's the auto name created. Now, we used sp help stats, but I would recommend that you can use another DMV called sys.dmdb stats properties. This DMV, I think, was added from SQL 2012 onwards. You may not find this DMV in the earlier versions of SQL Server prior to 2012. If I execute this, and of course I'm filtering on person.person2, I get some more information about the statistics, which is the name and when was it last updated. Then you can see that there were 19,000 rows approximately in my table, but not all the rows were sampled. So only 8,529 rows were sampled to create the statistics data. It's really like now you're not running you're not organizing a birthday party for your child. You're basically organizing a marriage ceremony, and the number of guests are like over 9,000 guests. It's a big party. You can't go and check with everyone whether they would like to have veg or non-veg. So what you do is you randomly call a few and you try to do a guesstimate as to how much food you need to arrange. So that is the sampling. And when you manually create statistics, you can always tell SQL Server that I want to do a full scan, or otherwise SQL Server by default does sampling. There's one more column here which is called as modifications, which is 0 here. And this is an indicator to SQL Server that only no rows are modified right now. SQL Server actually needs to keep a track of the number of changes that have happened to this column last name, because based on that only will SQL Server automatically update statistics. There is a basic formula in place, and I will talk about that later. So right now it's a new statistics object. No modifications have happened after the stats object was created. So modification says 0. Let's move on. So now you see statistics object are automatically created, and And yes, I want to tell you a few more things about this creating of statistics. Now remember, SQL Server has two types of stats from a column perspective: single column stats and multi-column stats. What you have just seen is the single column stats because you were filtering on only on last name. Now I have another query here. This time I am filtering on first name, middle name, and last name. When I execute this, I get one record returned. And now if I go back and run this query and I execute, it will show that now I have three stats object. Of course, the first one was created in the beginning, and I have two more stats object, and this is for the first name, the middle name, and the last name. And you can see the column here numbers, which is like um, 7, 6, and 5. Now the interesting thing is, why am I showing this to you? That because SQL Server can only create single column statistics automatically. By default, SQL Server cannot create multi-column stats. Multi-column stats can be created in two ways. One, you manually create multi-column statistics using create stats object, or you can when you create indexes, then behind the indexes automatically stats are created for the index keys. Then multi-column stats are created. Otherwise, SQL Server will always automatically create only single column statistics. And now again, you can see number of rows sampled, modifications all zero. So now you have three stats object. So that's about creating. And again, you are able to create statistics and the object because create stats, auto create stats is turned on. So now, yeah, I was just trying to show you is what the hexadecimal value and all of that is, but that's not really important. Now I will show you how the statistics objects are updated. Now, if you, as I run this statement again, let me execute this, and I will show you that modifications for all the three columns are 0, 0, 0. Now remember, we just talked very briefly about creating these statistics. Now let me just quickly talk about updating these statistics. How are statistics updated? Well, there is a very simple formula that SQL Server uses, and I am not talking about some exceptions of using trace flags, etc. That simple formula is 20% of the rows plus 500. That is the kind of change the SQL Server will look for before updating statistics object. And what does that mean? I am just doing, so you know that there are 19,972 rows, and I am computing 20% of 19,972 plus 500. If I do this, and I get that approximately 4,495 rows need to change before SQL Server will automatically update statistics. And why will it automatically update? Again, there is a database property which is SP. Why am I using SP all the time? Not SP. Auto update stats. So this is the second property. There are two properties here: auto create stats and auto update stats, and by default both of them are turned on. So if auto update stats is turned on, SQL Server will automatically update the statistics when this threshold is met. So this is a very simple formula. Now let me just go and do a small modification. Now you can see I'm trying to update the first name, and I'm just setting the value to Amit. But look at my criteria. I'm saying where business entity ID is equal to 4490. Now when I say 4490, I'm just trying to keep it a little lesser, slightly lesser than whatever my threshold value is, just to show you that stats are not going to be updated automatically if the threshold is not met. When I execute this, you can see 3685 rows have been affected. Of course, business entity IDs are not really from 1 to 4490, so 3685 rows have been affected. And let's go and look at the stats object here again. And when I execute this, you can see that for one of my objects here, you can see 3685 stats object. This is number 5, which is first name, and modification counter keeps a track of things, 3685. And can anyone answer? Well, nice question here, a random question for all of you who are listening very carefully, and I will understand how well are you listening. You have a new statistics object here. You remember in my previous execution, I only showed you 3 stats object. Now, where has this fourth one come from? Anyone, please use the chat window to answer. Where has this fourth object come from, and what does this mean? How did this come automatically? Anyone? And if you know where it has come from, can you also tell me which column is this? Okay, I am getting some responses, but not too many. Okay, so Abhijit has responded, Karthik has responded, Aizaz has responded, Selvani, Arun, Ravi Kumar, Redmi. Wow, many of you have responded, and most of you are correct. This has come from that update query. And remember, update query was putting a filter on business entity ID. And just like my previous explanation, the optimizer needs some information about business entity ID, which is how many rows actually match this criteria. So it first creates the statistics and then creates the plan. So that's wonderful response from many of you. That's wonderful response from many of you. Okay, great. So let's move forward. Now you can see that 3685 is the number of rows that got affected. So if I keep running my query as many times as I want, and then I look at the stats object again, you will see that it is still 3685, and update stats has not kicked in. So what next? The next thing is I will update a few more rows, because you know that threshold was 4495. So let me go and update 1,000 rows more again, and let me execute this. Now 645 rows have been updated. So now if I look at the stats object, and let me see if we are good beyond the threshold 4330. Okay, 4330 is still not good enough. Is it 20%? So let's put this here. I have this small 4330. Is it 20% plus 500? Okay, it's about 21%, and which means plus 500. So not 20 and plus 500. That's the formula we need. So it's still not good enough. So if I execute this, and then let's go and look at the select object, no, still not good enough. Let's go and modify another 1,000 rows, and then we will go beyond 20%. And now when I look at my select the system DMV 4975, now we have crossed the threshold. So let's go and execute this. Now you will see, now stats object must have been updated. And can we see that? Ooh, not yet. Where are we going wrong? 4975. So what's my strength here? 20% plus 500. 4495 is the update I need. 4495. And what am I getting here? Row sampled. Now I should have the updates running in by then now. Let me just modify. Am I modifying 645 rows again? Let's look at what the threshold is now, plus 500, 5620. And this is on my fifth column, which is first name. And I run the query. There's one thing that you need to know is that SQL Server will update statistics only when the next query comes in after the threshold is updated. It won't automatically update the stats when it sees that the threshold has crossed over. It will only execute. It will only execute when it knows that the threshold has crossed over 20%. And now I can see something funny, which is that my modifications are. So let me just go and run on first name. Oops, so I just wanted to run a query on first name. So which is my first name query. There you go. And let me see. I hope all my formulas were correct. Okay, friends. So the interesting thing here is why it is not updating is because my auto create stats is actually turned off. And that's my guess. This is the one. My auto update stats is right now turned off, and I can just show it to you and confirm this to myself also. Which database this is? It is AdventureWorks 2012. And when I go to the properties, I was so surprised to see that. But anyway, let's go to options, and you have auto create and auto updates. Is true. So let me on adventure auto database stats on. Now this is turned on, and I will execute this. And now that is very strange as to why it's not updating. Anyway, I will let this here for a moment and move on to the histogram. And I'm going to troubleshoot this a bit later as to why it's not automatically updating. The auto update stats is actually turned on. I just did that. Select 4430 is beyond 20. There you go. So it looks like that I was running a multi-column select statement and it did not update the stats. But when I only do it on first name, it updates the statistics. Now you can see for my first name column, stats have been updated and modification counter has been set back to 0. And here you can look at the update time. So these were the columns 6 and 7 that were created almost at the same time. And now this one is updated. So that's probably a little bit of catch there. This was a multi-column select that I was running, and on a single column, it updates. So that is how SQL Server is automatically updating the statistics. Now, friends, a couple of things again about update. I can't show everything in a 1-hour webinar, but there is another property called update stats asynchronously. I did blog about that. So if you search on SQLServerGeeks.com, you will get it. That's one of the properties. There are some trace flags which will tweak this 20% thing. Now think about a very large table with, let's say, 1 billion rows. And you really don't want 2 million rows to be 20 million rows to be changed 20% if you want to update stats for that particular table. So what happens is there is a trace flag. I don't remember it offhand, but if you put that trace flag on, if you turn it on, the percentage keeps decreasing as the number of rows in a table increases. So there are many more things about creating statistics and updating statistics which you really need to explore if you want to dive further deep into statistics. Friends, now let's move on to really decoding what statistics objects look like. Now before I move towards that, a quick check with all of you. Did you all understand and follow the concepts and the demos around creating statistics and updating statistics? Please put yes or no in the chat window, or if you have not understood it very well, you can say so. That's also fine. But put down some feedback so that I can move on to the next part of the demo. All right, great. Thanks for the response. I'm getting good response from all of you. Yes, the concepts were not were pretty simple. So glad that you have followed. Now we will get into a bit of deep dive into what statistics objects do look like. So for that, I am now going to actually create a different. I'm going to use a different object. So this time I'm using AdventureWorks 2008. Let me first drop the stats if I already have. There is a table here called sales order header. And in this sales order header table, there is a table which is called total. There is a column which is called as total due. Look at this column, total due. Now I am going to manually create statistics on total due. And why am I choosing this column? Because this column has variety of values. It has a 1-digit and 2-digit numbers and all the way to 5 and 6-digit numbers. Good distribution of data from low range values to very high range values. And this will create nice statistics for us. So I go ahead and use this command, create statistics total due on sales order header, and the name of the statistics is total due, and the column here is total due. And I execute this. Now when I look into there is a command called dbcc show statistics. Using this command, I can see what my stats object look like. Now when you look at this statistics object, let's decode this further. So name of this statistics total due. This is just the header information. When was it updated? Number of rows, 31,000 rows sample, 31,000. Now look at this. When you manually create statistics, SQL Server is by default using full scan. You can hint SQL Server not to use full scan, but I did not do that. So it by default uses full scan. And so yeah, number of rows and row sample were all both 100%. And what you see is the histogram here. Histogram is really like a bar graph where you have buckets, and each bucket has a range 1.5 to 2.5, and then 2.5 to 4.4, and then 4.4 to 5.5, so on and so forth. Now, when you have a histogram has steps, and you can see the number of steps that SQL Server has created here for this histogram is 198. As far as I know, there could be 200 steps. That's the max limit. Sometimes if there are null values, then SQL Server will have 201 steps. So when you see this range Heike starting from 1, and if I scroll all the way down, you will have 198. And look at the last value, which is really a 6-digit number, 247913, and the lowest is, sorry, and if I scroll up, the lowest is 1.5. So from a 1-digit number to all the way to a 6-digit number. That's the histogram, and this histogram is very critical for cardinality estimation, which I'm going to explain shortly. There are other informations here like density, average key length, etc. For density, don't use this one. You should use this one. You can ignore this. This is the density that SQL Server uses now. And how is this density computed? I think it's 1 divided by the number of unique values that a particular table has. That is the density factor. Now SQL Server uses density and this histogram table to compute cardinality estimation, and cardinality estimation further helps the optimizer to decide which plan or which plan operators or which plan actions SQL Server needs to take. Okay, friends, so let me now, what do we want to learn next is what is this histogram, and let me just explain you some of these computations, and then I will show you how these computations are being used. So first one here is range Heike. Now, what does range Heike mean? Think about a simple graph and a bar chart, for example, and these are the boundary values. 1.5 to 2.5, and then from 2.5 to 4.4. So these form the boundary values of your histogram. And the range rows here tell you that how many rows are between two range Heike values or two boundaries, but not including either of these values. So for example, between 11.039 to 14.297, there are 36 rows, not including these values. How can we test it? So let me, they're saying 2.5305. Let me take 2.5305. No, that's not a good number. So let me take these ones. So what I can do is I can actually take these verification queries and let's open a new window and do a vertical tab group so that things are easy to identify. Sorry. So let me take this range high key of 11.0. So I'll copy this here and put this here, and then 14.2987. Okay. And let's execute this. And when I do this, you can see I get a return of 36, which means there are 36 rows between this value and this value, but not including any of these values. So that is what range rows mean. So quick check with all of you. Is range rows clear to all of you? Please say yes in the chat window. Webinars are not easy to deliver when there's only the instructor talking and I can't really hear so many of you who have joined today. Okay, great. So that's range row between the number of rows between the two values. Then there is a column here called EQ rows, and it's very simple to understand. 58 rows are equal to this particular range high key, which is 14.2987. And when I copy this and I'll put it here, number of rows count star equal to 14.2987. When I execute this, you will see 58, which means 58 rows are equal to this value. Very straightforward. Range rows and equal to rows. Again, put down yes in the chat window if you have understood what is EQ rows. Great. Now, friends, you want to see how cardinality estimation is done and where is the optimizer using this information. So let me ask you a very simple question. If now that you know that there is a statistics object for this total U, and if I ask the optimizer, hey optimizer, can you tell me how many rows are equal to 14.2987? Can the optimizer tell me, Mr. Bansal, the value is 58? Yes or no? So we say select star from sales order header. Oh, sorry. Seriously, this is due to lack of sleep. That query is already here. So if I select this and I turn on actual execution plan and I click on execute, I get 58. And when I look into the execution plan, and now I will show you where exactly is the optimizer using this information. And you have the filter, which is compute scalar. Okay, no, we can use this one because there is count star. So I'm filtering. And can you see this now? So you can see that actual number of rows is 58 and estimated number of rows is 58. This information estimation is coming from statistics because you are directly filtering on a range high key, and equal to rows clearly tells the optimizer that there are 58 rows that match the range high key. Okay. Now let's move forward and understand distinct range rows. For distinct range rows, what does this mean? This means that, let me go back one step. If there are 36 rows, between 11.039 and 14.2987, distinct range rows tells us that how many values are distinct here. Which means there are 4 distinct values between 11.0 and 14.2. There are 36 rows, but there are 4 out of those 36 rows, 4 values are distinct, which means others are just duplicates of those 4 distinct values. How can I test that? I should actually go ahead and distinct. So I can just take 11.03 here. And you can see I've used the distinct clause here, and 14 I should copy and put it here. And now I will select distinct total due between the two values, and I click on execute. And what do you see? You see 4 distinct values: 11.3, 12.9, 13.1, 13.6, and all of them are between this. This is what distinct range rows tells you, which means there are 4 distinct values. So friends, I again need in the chat window, is it clear to you what are distinct range rows? Abhishek is asking me a question. Okay, can you please check between 15.44 and 16.55? Okay, 15.44 and 16.55. There are two distinct range. Okay, Abhishek, your wish is granted. Let me just quickly do this. 15.44. I'll copy this. That's what you want me to do. And total due between 16.55. Let's execute this, and you get two distinct values, and the optimizer tells you that. Okay, Abhishek, all good. So friends, I need a yes from you if all of you have understood. Okay, great. You've already put down yes. Thank you. So friends, now this is distinct range rows. Now let's go to the last column in this histogram, which is average range rows. Let me just expand the window a bit because this average range rows will take a bit of time to explain. What does average range rows means? Very simple, friends. 36 divided by 4. 36 divided by 4 will give you 9. 21 divided by 1 will give you 21. 14 divided by 2 will give you 7. So on and so forth. Likewise, 38 divided by 10 will give you 3.8. So what does average range rows means? If distinct range rows are 4, then average range rows tells you how many records you have per distinct value. If the total number of rows are 36 and distinct are 4, which means there are 9 rows per distinct value. That's a very, very simple calculation SQL Server uses here to compute average range rows, which means if there are 38 rows between this and this range Heike, and there are 10 distinct values, then of course there are 3.8 rows per distinct value. Very simple calculation. So friends, is average range rows clear to all of you how that is computed? Now I'm sure this formula was very simple to understand, but now you want to see how is the optimizer using this value. Like you saw how SQL Server is using equal to rows, how is optimizer using average range rows? Now the optimizer will use average range rows when you are trying to search, or you put down a filter value between 16.8 and 23.7, but not either of them. SQL Server clearly knows how many records match 16.8292, which is 39. SQL Server clearly knows how many records are equal to 23.7465, which is 122. However, SQL Server does not know the number of records that are equal to a particular value between 16.8 and 23.7. It could be 17, it could be 18, it could be 19. All the values between these two ranges, what are the number of rows equal to that value? SQL Server doesn't know. So SQL Server will always estimate that to be 3.8. Let's test that. So I can simply say 17. Now tell me, where does 17 belong? 17 belongs between 16.8 and 23.7. This is where 17 belongs. And number of rows are 38, but there is no range Heike for 17, which means the number of rows equal to 17, histogram cannot tell us. But this computation is what SQL Server is going to use, estimate of 3.8. So when I execute this, no number of rows, but it will always be 3.8. So when I go into the execution plan and I look at filter here, you can see estimated number of rows is 3.8. Where is it coming from? This is coming from average range rows, because 17 is not a range Heike, so SQL Server does not have that exact information about the number of rows that matches. So it is using that approximate statistics value of 3.8. And why not? Even if it is 18, or for that matter 19, anything between below 23.7, and I execute, it will always be 3.8. So again, when I use 17, 18, or 19, it is always 3.8. So friends, is the last column, average range rows, clear to all of you? I just recorded this video yesterday, and I had put this up on YouTube, and I will request Satya to share our YouTube channel to all the attendees, which is youtube.com/SQLMaestros. and you can see this in a more detailed fashion. So that's youtube.com/SQLMaestros. So friends, I showed you the internals of statistics, in sense how they're created, how they're updated, how they're maintained, how is the histogram used. I showed you equal rows, average range rows. Likewise, the density factor. Density factor is also used in multiple places in cardinality estimation. And I can, what time is it now? I still have a few minutes. So maybe let me just pull out one example to show you how the density factor is used. Oh, I'm already getting a lot of questions. Okay, sorry. So friends, the YouTube channel link is there. You can always subscribe to that channel and get more videos right at your doorstep. So let me use cardinality estimation, and let me use notes 2. I just want to show you how the histogram is used, not part 3. Let me use part 1. Do I have part 1? Okay, there you go. Well, all these are already blogged. For this is using parameters, so I don't want to use parameters. That's a little tricky. Let me, if I see if I have something else. Let me use part 2. I think part 2 should have something more. Yes. Let's see 30% guesstimate. Okay. Okay, dear friends, let me show you this quick example so that you've seen how histogram data is used, but you have not seen how is the density value or density factor being used. So I'll show this as an example. I'm using AdventureWorks 2012, and here is again sales order header, total due, and if I turn on actual execution plan, let's go and execute this. And when I look into the execution plan, let's go and filter here, and you can see that estimated number of rows is 1.7 and actual number of rows is 1. Okay, great. If I change the value to something else, and when I execute this, and then if you look into the execution plan, now you can, come on, pop up, please come up. Yeah, there you go. Now you can see estimated number of rows is 1.9 and actual number of rows is 21. So what are you seeing? You're basically seeing that as I keep changing values here, the cardinality estimation obviously changes based on the filter that we that the values literals that we enter. Now you see 1.06 and actual number of rows is 0. So of course that is expected, and you know, because there is histogram playing behind the scene. But what if, friends, you actually, instead of declaring a constant, a literal, you put that in a variable and you supply the variable here. So if you do that, the problem is optimizer will not have the value of this variable until runtime. And then SQL Server has to do, the optimizer has to do some guesswork. So when I execute this and I look into the execution plan, now you will see that the optimizer is estimating 6.6. And what I want to show you here is, irrespective of whatever value you put, it will always be 6.6. Now, when I go into the execution plan, you can again see that it is 6.6. And if I change the value to even something else as simple as 32 or whatever it is, it will again give you an estimate of 6.6. Now, the point is, what am I trying to tell you? I'm trying to explain you that if you put this as a constant, the optimizer, while preparing the execution plan, has this value. So it can use the statistics and compute that cardinality estimation. But when you use local variables like this, and replace the constant with the variable, then the value of the variable is not available until runtime, because the assignment of value to the variable happens at runtime. At that point, SQL Server just really cannot use statistics. Then the question is, where does 6.6 come from? 6.6 comes from density factor now, and let me explain that to you. The formula that SQL Server here is using is total rows into density, where density, as I told you earlier, is 1 divided by number of distinct values. So my total number of rows is 31,465, and distinct number of rows is 4754. And if I do this computation, which is total number of rows into the density factor, and remember density is already computed as part of statistics, I get 6.6. So 6.6 is the default estimate that SQL Server will always use when it has to deal with local variables for total due. That's where density factor is being used. So this is just one of the examples where how density factor is used, and you can now fathom and comprehend that it's not easy. There's a lot of complex formulas also. This is a simple one, that the optimizer is really like a black box. A lot of things happen inside, but these are some basic examples that I wanted to show you, so that you can understand that how statistics are being used, how histogram is being used, and how density factor is being used for cardinality estimation, which helps the optimizer in generating a good optimized plan, and that in turn helps your query run fast and good enough, so that you're happy, your users are happy, your business is happy, the entire SQL Server community is happy. That's the whole objective. With this, I bring a closure to the webinar and this demo, and I will take questions now. And but before the questions, I think Satya must be posting a Facebook group message with the pic here. So all of you, please respond. Give us your feedback on that Facebook group. Satya will give you the link in a while. So give us your feedback. How well did you like it? And but before I take in the questions, I will just hand over quickly to Manohar. He just want to talk about a bit about the precons, and then I will come back and take questions. So stick around. We have more discussions to happen. Over to you, Manu.
Thanks, Amit. That was a wonderful session, and I see a lot of questions already. So please do post your questions here, and if we are not able to answer all the questions, please do post your specific questions on the Facebook group, and we'll try to answer them. I would like to quickly cover the pre-conference trainings that are available at the Data Platform Summit this year. So the pre-conference trainings are happening on 7th and 8th of August, the full day trainings. The more information is available at dps10.com. So I'll quickly walk you through what all pre-cons are available. So we have Troubleshoot and Optimize SQL Server Like a Pro by Dmitry Kotkovich. He's a Microsoft Certified Master from US. And we have Sunil Agarwal, who has been a very popular speaker for the last, at our previous conferences. He'll be doing how to migrate your on-premise database to Azure SQL DB and managed instance. Razarat, a BI expert and a well-known MVP and from New Zealand, is doing a full-day pre-con on Power BI from rookie to rockstar. Dr. Leila Atati, she's a data scientist and MVP from New Zealand again. She's doing two pre-cons. The first one is leading edge data science with Microsoft tools. World-renowned BI SSIS expert, Andy Leonard, he'll be doing a day of intelligent data integration with SSIS and Azure Data Factory. Madan Gajendran and his team, the Cosmos DB team, will be doing a full-day workshop on Cosmos DB. The second pre-conference by Dr. Leila Atati is building intelligence applications using the Microsoft AI platform. If you're really serious about learning R, this is the session for you, because the data science expert and MVP from UK, Steph Flocky, she's doing a practical R for everyone. Sanjay Mishra and his team, the Data Cat team from Microsoft, will be doing a full day training on how to build a scalable data architecture in Azure. Joey and Denny are coming back to the conference this year again, 4th year in a row. Joey will be doing a full day training on Linux for SQL Server DBAs. Peter Myers, who has been a very popular speaker last year, is coming back and he's doing a full day training on 0 to analysis services. Denny will be doing the pre-con on availability and disaster recovery, both on-premise and in Azure. More information is available at dps10.com, which pre-con trainings are happening on which day. There are 2 days. Remember, it's 7th and 8th. You can attend 2 pre-cons. If you have more questions, please drop us a line. If you want our help in talking to your manager or talking to your company, please do reach out to us at contact@dps10.com or the numbers displayed on this slide. This webinar will be recorded, so all this information can also be viewed later or is also available on dps10.com. I will quickly hand over to Amit to take the questions. There are a lot of questions for you, Amit.
Thank you, Manohar. So I can see that there are questions coming in. So let me take questions now. And yeah, but for others, friends, do connect with me before I take in the question. Just want to share a few URLs. So that's there for SQL Maestros. You can follow me on Twitter here, which is twitter.com _Bansal. That's my Twitter handle. And SQL Maestros is under /SQL Maestros. Very simple to remember. You can also explore some options here on SQL Maestros about advanced training. I particularly want to bring your attention to hands-on labs. This was a pet project that we started 2 years back because we all believe that the best way to learn is to do it yourself. And that's why we created this portal, which has more than 100 labs in many topics around SQL Server and Microsoft Data Platform, AI, machine learning, Azure Data Factory, Azure SQL DB, Azure SQL Data Warehouse, a lot of Azure stuff as well as SQL Server stuff out there. And you can create your free account and practice these hands-on labs. And yes, DPG and everything Manohar has already spoken about, so I'm not going to spend much time on that now. Do join our groups and friends. Satya has given the link and we will approve your membership as you come in. And here is the link, please. A pic has been posted here of our webinar today. Generally, when we do in-person events, we take group pic with everyone physically present, but this is a kind of a remote pic. So please go ahead and give your feedback there as to how well did you enjoy today's session and was it worth your time. With this, those who are now leaving, thank you very much for your time today. And I hope to connect with you soon in another webinar or any other video. My Twitter handle is _Bansal. Thank you for joining me today and have a great day ahead. And now I will take questions. So Abhishek says he couldn't really understand histogram very well. So Abhishek, I would suggest you please see some videos there in YouTube channel that I've put on statistics, youtube.com/SQLMaestros. Some of these demos I have put up in YouTube also. Still, if you're not able to understand, just drop me an email and we'll see what we can do. Thank you. Fenil has a question, how can we check the data is correct or not? So Fenil, I think your question is, how can you check whether the statistics data is correct or not? Well, you got to trust SQL Server that the data that is computed is correct, because it is a pretty popular product and it's the leader in the database category, being used by thousands and thousands of customers worldwide. Some of the largest companies use SQL Server and in most demanding conditions, and it's a proven product, so you got to trust it. That's what I would say. Else you can always dive deep into statistics algorithms as to what SQL Server team uses, and of course you can play around more with that. Thanks, Fenil. Next question is from Kedar. What is the purpose of estimated data size? So Kedar, you looked into the execution plan. Well, thanks people for the messages. A lot of good messages are coming in. Thanks so much. Please give your feedback on Facebook also. I will really appreciate that. Back to Kedar's question. What is the purpose of estimated data size? The purpose of estimated data size is a little different and is out of context for this session, but I will still answer it. It is used for by the optimizer to estimate if SQL Server needs, how much memory grant SQL Server needs. Remember, all of this data is computed and processed in memory. So if you have a huge amount of data size, estimated data size, and you're, let's say, sorting, then SQL Server needs that much memory. So it's really for the memory grant for that particular query. Next, Murali, please explain, is there any difference between SP update stats and update statistics? Yes, Murali, there are some differences, but both can do the job. So why don't you please look into MSDN documentation? I wouldn't really remember the syntaxes and syntactical differences between the two. So so the MSDN documentation, or whatever, the books online or SQL docs are the best sources for these. Jay Mohan has a question. Limitation to step is configurable because you mentioned that max is 200. No, the steps is fixed at 200 steps. That is not configurable. It is designed that way. I remember earlier versions of SQL Server actually had more than 200 steps. I think 6.5 or 7 maybe, but then I think from 7.0 they fixed it at 200, and that's a lot to do with how statistics work. So with this, when are multi-column statistics created? Akshay has a question. So Akshay, multi-column statistics are created when you are creating a multi-column index, or when you are, let's say, manually creating multi-column stats using create statistics statements. Then they are created. Yes. Right, friends. So with this, I will close the webinar now. Thank you very much for your time. I hope all of you enjoyed and it was worth your time to attend this session, and hope you learned something new. And I will connect back with you soon. The best way to learn, and do subscribe to our blogs on Data Platform Geeks. Also, there's a new blog section out there, and do follow us on Twitters. A_Bansal is mine. For SQL Server Geeks, it is just SQL Server Geeks, and for SQL Maestros, it is SQL Maestros. Twitter.com/the links. You can also connect with me on Facebook. That all the links are there in the chat window. Goodbye and have a nice day. Thank you.
Thanks, Amit. Thank you, everyone. Have a good day.